Hi everybody, in this video we're going to go over section 2 of chapter 1 and we are going to talk about applications and modeling with linear equations. So this subject or this section is all about word problems. Now word problems are particularly difficult because we actually have to take something that is written in English and turn it into something that is, well, I guess for lack of a better term, written in math. But for you, I have a handy-dandy six-step procedure that you can use to solve these problems. And the first step is, well, read the problem. Figure out what it is you are supposed to find and what information is relevant towards that solution. Will help you solve that solution. Sometimes your word problems will have stuff that is relevant. Sometimes you'll have stuff that is superfluous. You need to actually use your critical thinking skills to figure out, to separate the relevant from the superfluous. Next, you want to assign a variable, typically x, could be something else, to the value of interest. Write down what the variable means, and then express other unknown variables or other unknown values in terms of that variable. And then the third part is actually the hard part, coming up with an equation that uses that variable and represents the problem. This is usually the most challenging part of any word problem. But once you've done that, you are off to the races. Once you write the equation, solve the equation. Once you solved it, hey, answer the question. Make sure that answer makes some sort of sense. Now what's the last thing you want to do? You want to check your work. You want to check your answer against the original problem. Okay, so let's get started. The first type of problems that you're going to have are going to deal with motion. And basically, the components of the motion problem is the distance, how far you've traveled, the speed, or the velocity. We're going to call it speed because velocity is a vector. We're not doing vectors just yet, which is typically denoted by r or s, and then the time, which is denoted by t. And as you all know, there is a linear relationship between the distance and time, and of course that is the speed. And of course, we can use what we know about literal equations to solve for r and also to solve for t. So these are the three equations. They're basically just three permutations of the exact same equation that we're going to be using for a collection of problems that we will call motion problems. And here is our first motion problem. We have Maria and Eduardo are traveling to a business conference. The trip takes 2 hours for Maria and 2.5 hours for Eduardo because he lives 40 miles away farther than Maria does. And we also know that Eduardo has a lead foot. He's going to be traveling on the average 5 miles an hour faster than Maria, and we need to find their average rates. So how are we going to handle this problem? Well, first the first thing we're going to do is go over to one book where I actually have it written down again right here. And we are going to solve this problem in one book. Okay, so what is step one? Step one is to read the problem. Well, we just got through doing that, and we know that we want to find the rates for Maria and the rate of Eduardo. So we want to find the rate for Maria, or the speed. Let's just call it speed for Maria, and the speed for Eduardo. Okay, step two. We want to assign a variable. Well, how about if we let r be equal to, well, let me call it r sub m. So this is going to be the speed for Maria. And if that's the case, then the speed for Eduardo is going to be r sub m plus 5, because Eduardo is going 5 miles an hour faster than Maria. And also in step 2, what you'll see is that we have a little table for you. And basically, this is going to be a shorthand version of this. We have Maria here, we have Eduardo here, and then we have our rate, we have our time, and then we have our distance. Okay, now the rate for Maria is r sub m. We don't know what that is. The rate for Eduardo is r sub m plus 5. Now we know that Maria travels for a duration of 2 hours, and we know that Eduardo travels for a duration of 2.5 hours. And how far did Maria go? Well, she basically went 2 times r sub m, And Eduardo went a distance of 2.5 times r sub m plus 5. Okay, cool. So these are the distances. We know that we know that Eduardo traveled 40 miles farther than Maria. So in step 3, we can actually use this table to figure out our distance, to figure out our equation. Now notice that Maria went a distance of 2 times r sub m. That's how far she went. Now, and Eduardo has to travel 40 miles farther. So if we take Maria's distance and if we add 40 to it, we will have the distance for Eduardo. And there is our equation. Now step 4 is to solve the equation. So let's go ahead and do that. Step 4. And of course what we want to do is we want to isolate r sub m on one side and everything else on the other. Now the first thing we need to do is we need to do a little distributing here. So we will have 2r sub m plus 40 is going to be equal to 2.5 r sub m plus 12.5. Okay, cool. Now, once again, we want to use the additive property to get the r sub m's to get all the functions with r all the terms with r on one side and all the terms on the other side. And also, we want to do it in such a way that we actually have positive coefficients. It makes life a lot simpler for us. So we're going to subtract 2 r sub m from both sides using the additive property of equality. And then we're going to subtract 12.5 from both sides. And if we do, these cancel, we have 27.5 over here. And that's going to be equal to 0.5 times r sub m. So now we could multiply everything by 2. And if we do, we will have that r sub m is equal to 55 miles an hour. So with that information, in step 5, we can state our answer. And here we have the Maria speed is 55 miles an hour. And then Eduardo's speed is 60 miles an hour. None of these guys are speed demons, that's for sure. Okay, now does it make sense? Well, it kind of makes sense. They're positive numbers. The units appear to be right, although we didn't really track the units all that well. So I guess it passes the sanity check. And then for step 6, which is our check. Well, if Maria traveled at 55 miles an hour for 2 hours, she would have gone 110 miles. If Eduardo traveled at 60 miles an hour for 2.5 hours, then he would have traveled 150 miles. The difference between these two distances is 40 miles. So this does indeed check out. Okay, so that's pretty much how you would do a class of motion problems. The next class of problems you will encounter are mixture problems. And here, you need to understand that the percent of concentration, if you want to figure out how much of a desired substance is in a solution, well, basically, if you have the percent concentration, you can multiply that by the quantity of the entire solution, and that will give you the quantity of the desired subject. And always remember that if you have the concentration of your final mixture must always be between the concentrations of the two solutions making it up. For example, you cannot buy 20 proof alcohol, mix it with 40 proof alcohol to get 80 proof alcohol. It doesn't work that way. You want to get something between 40 and 20 proof for you luscious out there. Okay, so what kind of problems are we talking about here? Well, here's one. Here we have a chemist that needs a 20% solution of alcohol. She has a 15% solution and a 30% solution. So if she combines them, she can only produce solutions that are between 15 and 30. She cannot produce a 10% solution, and she cannot produce an 80% solution. Only between 15 and 30. Now, the other part of the question here is how many liters of the 15% solution should she add to the 3 liters of the 30% solution to obtain her 20% solution. Well, coming back to OneNote, here we are. Well, here's the question. Now, and this using our 6-step approach, step 1, we need to know how much of the 15% solution do we need to make a 20% solution. Apologize for my lousy handwriting. All right, so that's step 1. Step 2, assign a variable. Okay, well, how about if we call x the amount of the 15% solution? Okay, and we also in step 2 have this table that we can use to figure out that to help us come up with our equation for step 3. So notice here we have in this table we have concentration, and these tables are actually a great way to help you organize your thought. We have liters of solution, and we have liters of alcohol. Okay, now first we have our 15% concentration. Remember, 15% in decimals is 0.15. Okay, how much liters of solution do we need? Well, we need X. That's our unknown. We don't know yet. Well, and if we mix, and if we have X liters of solution of this 50% solution, then we will have 0.15X liters of alcohol. Okay, our next solution is our 30% solution, which of course is equal to 0.3 as a decimal. How many liters of solution do we have? Well, here we will have 3 liters, and therefore the number of the liters of alcohol that we'll have is going to be equal to 3 times 0.3, which will give us 0.9 liters of alcohol. Now we're going to add these two, and when we add these two, we want to have a 20% solution. And how much alcohol are we going to have? Well, we're going to have basically the whatever we got from the 15% X for the amount from the 15% solution, plus 3 for the 30% solution, and then how much pure alcohol are we going to have? Well, we are going to have 0.15X plus 0.9 liters of pure alcohol. So this is how much alcohol we're going to have, and we want to have, and we want this basically to be equal to 20% of the alcohol in here. So our equation is going to be 20% of this quantity, which is 0.2 times x plus 3, and that going to be equal to the combined to all the alcohol and these two things added together, which will be 0.15x plus 0.9. So that is the equation that we need to solve. Step 4, let's go ahead and solve the equation. Okay, we can do that. Once we figured out step 3, we are good to go. So in step 4, we isolate x, and of course, the first thing we need to do is use the distributive property here, and that will give us 0.2x plus 0.6 is going to be equal to 0.15x plus 0.9. Now we want to use the addition property to get all the terms of the next in it over here and everything else over there. So I'm going to subtract 0.15x from both sides. Okay, and then to get this 0.6 over here, I'm going to subtract 0.6 from both sides. Minus. All right, so when I do that, these cancel. These cancel. Over here, I have 0.05x, and that is going to be equal to 0.3. Now, when I divide both sides by 0.05, kind of like multiplying by 20, of course, these cancel, and I will have that x is equal to 6 liters. Okay, so step 5, stating the problem, we need 6 liters of the 15% solution. And then step 6 is to check. And if we do, well, let's just go ahead and see how much alcohol we will actually have in our 15% solution if we have 6 liters. Well, it turns out that 6 times 0.15 is 9 liters. I'm sorry, 0.9 liters. So in the 15% solution, 0.15 times 6 is equal to 0.9. All right. In the 30% solution, we have 0.9 liters of alcohol, and that combines to 1.8 liters of alcohol. All right. Now, what about the 20% solution? Well, we actually, if x is equal to 6, then we have 9 liters of the 20% solution. And 9 times 0.2 is equal to 1.8 liter. So everything seems to check out. Awesome. Okay, and this moves us on to our third problem, class of problems, which has to do with simple interest and investment. And in our last video, we've talked about the simple interest formula. This is the interest from the simple interest formula. And of course, P is the principal or present value. R is the interest rate, and T is the time. Now, in the previous lesson, in our previous video, we talked about this from the perspective of a loan. Here we're going to talk about it from the perspective of an investment. So here, P is the amount of money that you put into an account. R is the interest rate that, once again, must be in decimal form that the institution, the bank, or whatever will pay you per year for letting them keep your money. And then T is the time that you've actually invested your money. And so this will be the interest that you will earn, not necessarily the interest you will pay. And here, oh, and there it is. And here is the problem that we're going to deal with. Here we have an artist that has sold a painting for $410,000. He invests a portion of this money for 6 months at a rate of 2.65% for 6 months, half a year, and the rest at 2.91% into another account for a full year. And his broker tells him that both investments he's going to earn a total of $8,761 in interest. And the question here is, how much should the investment at each rate, how much should be invested at each of the rates to obtain this amount of interest? So that's the problem. We want to figure out what portion of the $410,000 do we want to invest in the 2.65% account and the 2.91% account so that he actually earns $8,761 worth of interest. Okay, let's come back over to OneNote and see if we can figure this out. All right, let's start off with step 1. How much should he invest at 2.65%? How much should he invest at 2.91%? Okay, cool. Step 2 is we want to assign a variable. Okay, so let's let X be equal to the amount of money invested at 2.65%. And that's the case, then $410,000 minus X is the amount of money invested at 2.91%. Okay, and now we can use this information to construct our handy dandy little table here. And here we have investment amount, the interest rate, the time or duration in years, and here we have the interest earned. Okay, now for the 2.65% account, 2.65%, which is equal to 0.0265, we're investing X dollars. We don't know what it is, so we're just going to call it X. Now, we're investing that at 2.65% for 6 months, which is 1/2 of a year. So the amount of money that we're going to earn from this is going to be 1/2 times 0.0265 times X, the amount that we invested. Now, for the other account, we're going to invest the rest, and that will be, oh, it's kind of poetic, invest the rest. I kind of like that. $410,000 minus X, and we are going to invest that at 2.91%, which is equal to, well, I forgot the percentage there, 0.0291 for 1 full year. And of course, the interest generated there is going to be 0.0291 times $410,000 minus X. Okay, and with that information, we can come up with our equation. Now notice that what we want to do is we want to figure out, we are going to have a total interest of $8,761. So for step 3, and we can use that to figure out our equation. And what is our equation? Well, that amount of interest, $8,761, must be equal to the interest from this account, 1/2 times 0.0265 times X, plus the interest from this account, 0.0291 times $4,100 minus X. Okay, so that's step 3. Step 4, this is where we get to solve. Now the first thing that we can do is we can simplify using the distributive property here and combining like terms there. And if we do, we will have 8761 is equal to 0.01325x, so that's what you get when you divide that by 2, plus 11,000, turns out that 0.0291 times $4,100,000 is $11,931 minus 0.0291x. Now we can still do some simplifying because we have a like term here and a like term there. So that will give us 8761 is equal to, combining these two, will be negative 0.01585x plus 11,931. And then finally, we can use the additive property to move the 11,931 over here by subtracting that from both sides of the equation. And once I've done all that, I will have negative 3170 is equal to negative 0.01585x. And now we can use the multiplicative property of equality and divide everything by negative 0.01585, negative 0.01585. Of course, these will cancel. And we have that X is equal to $200,000. All that work to come up with a nice even number. Well, if that's the case, if X is equal to $200,000, then it turns out that 410,000 minus X is equal to $210,000. And we can use this for step 5. So we want to have $200,000 in the 2.65% account, and then we want to have $210,000 in the 2.91% account. And I guess it sort of makes sense. I mean, they're both positive numbers, so they would pass a basic sanity check. Of course, if one of these is negative, you made a mistake somewhere. So for step 6 is to check. Okay, well, if you invested $200,000 into an account that pays 2.65% interest for half of a year, you would have an interest $2,650. Okay? If you invested $210,000 into an account that pays 2.91% interest for a full year, you would have $6,111. And if you add those together, you would have $8,761, which is basically what we were looking for. So this does indeed check out. Okay, so that is pretty much what we have for word problems. The other kind of word problems you are going to be dealing with linear models. And what is a mathematical model? Well, basically, a mathematical model is an equation or an inequality that's used to describe the relationship between two or more quantities. It's used to predict the behavior of a certain physical phenomenon or perhaps a certain contrived phenomenon or an economic phenomenon. And of course, if those models are linear equations, then we have a linear mathematical model. Now here is an example of a linear mathematical model. Here we have the projected per capita healthcare expenditures in the United States for Y is in dollars and X is in the years after 2020 is given by this linear equation right here. And the question is, what is the per capita health expenditures for the year 2018? Okay, well, if 0 corresponds to, and I'm going to actually do these right here, 0 corresponds to 2010, then 8 corresponds to 2018. Okay, so we're going to let x equal to 8, and then we will basically just go ahead and compute y is equal to 416, substitute 8 for x, plus 8042, and if you do, you get the answer of $11,370. And that's what the expected healthcare expenses will be in the year 2018. Okay, now part B, here we have if the model continues to describe the healthcare expenditures, when will the per capita expenditures reach $13,000? So basically, with this model, we want to figure out what value of x will cause y to be equal to $13,000. So let's go ahead and do that. That is going to be 13,000 is equal to 416x plus 8,042. Okay, but the first thing we want to do is isolate all the terms with an x in it. That's this one right here, and we can do that by subtracting 8042. And if I do that math, I'm going to do it over here. 8042 or 13,000 minus 8042 is going to be equal to 4598, and that will be equal to 416x. All right, cool. Well, then we use the multiplication property of equality and divide both sides by 416 to isolate the x. And if we do, we will have that x is equal to 11.9. So in the 11th year, the expenditures, I didn't think we have room for that, will reach $13,000, kind of like the end of the 11th year. Well, so in the 11th year, since the 0th year is 2010, the 11th year corresponds to 2021. So that is the year when the per capita expenditures will reach $13,000. Okay, now for the rest of this video, I'm going to go over a couple of homework problems that you might have some questions about. And this is the first one. Here, this is a modeling problem, but we have here, the problem goes as follows. When the concentrations of formaldehyde in the air exceed 33,000 micrograms per cubic foot, a strong odor and irritation to the eyes often occur. Now here we have a room with floor dimensions that are 10 feet by 10 feet by 6 feet, and it uses the equation to model the amount of formaldehyde in the room after X days, and that's actually the amount of micrograms of formaldehyde. And the question is, how long will it take before a person's eyes become irritated in that room? So we're going to go over to OneNote to work on this, and here it is. So notice that we have the equation F is equal to 100,950 times X. Now this is formaldehyde in micrograms. Now what we have here is that your eyes will become irritated at 33 micrograms per cubic foot. That's kind of like our F threshold. But notice that this is a density, okay? And this is in absolute grams. So to solve this equation, we actually have to use this density, our information about the volume in the room, to come up with a threshold value for F. So in this case, our F threshold value, i.e. when the amount of formaldehyde in that room, which will cause your eyes to become irritated, is going to be equal to the density, the threshold density, which is 33 micrograms per square foot per cubic foot, times the volume of the room, which in this case is going to be 10 feet. I forgot the foot cubed here. Times 10 feet times 6 feet, or basically 33 micrograms per per cubic foot times 600 cubic feet. And if you did that math, you would come up with 19,800 micrograms of formaldehyde. This is the value that we want to put in for F to figure out what X is. Okay, so this is our F, and now we want to solve for X, and we can go ahead and do that. We will have 19,800 micrograms of formaldehyde. That's going to be equal to, forgot the zero there, my apologies, 100,950 times X. Now, of course, we can solve, the way we solve for X is dividing both sides by 100,950. And if we do, we will have that X is equal to 0.196137 days. Now, in your homework problem, they're not going to ask you, they're going to ask for the answer in hours. And of course, you can get that by multiplying this by 24. And that will give you that X is equal to 4.7 hours. Okay, and I think they wanted it down to the nearest hour, and if that's the case, this would round up to 5. Okay, now the other problem that you're going to have, which might be of interest to you in your homework, is this one. Here we have two high-speed ferries that leave at the same time from a city and go to the exact same island. And the first ferry, the Cat, travels at 38 miles an hour. The second ferry, the Bird, travels at 28 miles an hour. And they want to know in how many hours will the ferries be 40 miles apart. The thing you need to know about this is that both ferries depart from the exact same city and they're going in the exact same direction. As a consequence, you have one ferry whose distance, we'll call this the Cat, is going to be equal to its speed times time, 38 times t. And then the other one whose distance is equal to its speed times time. Okay? And the question here is, well, when are their distance, in how many hours will the ferries be 40 miles apart? Well, that's just nothing more than the absolute value of, or dc minus db being equal to 40. Of course, doing the substitutions, that is 40 being equal to 38t minus 28t. And then, of course, simplifying this is pretty straightforward. We combine these. We have 40 is equal to 10t. In that case, t is equal to 4 hours. And there you go. That's pretty much all there is to it. And that is all that I have for this particular assignment. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.